Okay, ladies, gents. So this is page 351, special triangles. And basically what it is, it's using what we know about Pythagorean theorem to help us find surface area and volume about prisms, usually hexagonal prisms, but it doesn't really matter how many sides are on the bottom. You can do it for any of them. Okay, so they give you a hexagonal prism here, and they say the base of it is a prism, is a prism with a regular hexagon. Regular meaning not this, it's boring or anything else like that. It means that all sides are equal, as you can see down at the bottom here. And they tell you that each of those sides are 8 centimeters. So 8, 8, 8, 8, and 8. Okay. The length of the prism is 12 centimeters. So they tell you, first, they want you to find the area of that hexagonal base. Well, to do that, first, we are going to break that hexagonal base into 6 equilateral triangles by drawing a line from vertex to vertex. And again, a vertex is a spot where 2 lines meet, okay, and they form an angle. So if I do that, I draw those lines across, I get 6 equilateral triangles. They're equilateral because this was a regular hexagon. And again, equilateral means all 3 sides are the same length. So you get this. So this triangle sitting right here is this one. So 8 centimeters, 8 centimeters, and 8 centimeters. And then what we're going to do is draw an imaginary line going down. If they're asking us to find area of the base and we have triangles, we are going to need to do area of a triangle formula, which is base times height divided by 2. And then we can just multiply it by 6. To do that, though, we need to know the base of the triangle. We do. Okay, it's 8, but we don't know the height. So we're going to use Pythagorean theorem to find that. So now that we have this drawn, there's a squared. We don't know b squared, the height, and we know c squared. So that's what I've filled in right here. Okay, so a squared plus, b squared, but I changed it to h just to remind ourselves that it's the height, equals c squared. So a squared was 4 because it only went halfway across this 8 centimeter stretch from our equilateral triangle. We're only interested in this part, just the 4. And then c is 8 squared, and we're trying to find that. So 4 squared 16, 8 squared 64, subtract 16 from both sides, and we're left with h squared is going to be square root 48. Now, every other example you've seen, I have then done the square root of whatever number sitting here, in this case 48, to bring us to a final answer. 48 is not a perfect square. 49 would be, and it would be 7. But we're going to be using this in a whole bunch of other calculations. So I don't want to bring it to a decimal and then round it, because that'll make it slightly inaccurate. So now we're going to just drop it under the square root symbol in here. And that's fine, because you're going to be doing this with a calculator anyways. So where did this formula come from? Well, this is area of the base. Okay, so we're trying to find the area of this side here. And remember, that side is made up of 6 equilateral triangles. So that's where this came from. Base times height divided by 2 is area of a triangle, and we have 6 of them. Then we just need to fill it in. Okay, so our triangle, how big's the base? It's 8 centimeters, because they were 6 equilateral triangles based on an 8 centimeter or a regular 8 centimeter hexagon. The height, we just found out, was square root 48. So that's what goes in here for h. Divide by 2. And then I have 6 triangles here. 1, 2, 3, 4, 5, 6 that makes up that hexagon. So that's why I've multiplied it by 6. So this will give us the area of this end of that hexagon. Okay. This part here, you can do that in your calculator in one shot. Do 8 times, hit your square root button, 48. divided by 2, it'll spit out 27.712. At this point, I'd like you to pause the video, grab your calculator, try that. Make sure your calculator does give you 27.712 so that you know you're hitting the buttons in the right order. If it didn't, play around with it, change something. You might have to do 8 times square root 48 hit equals, then divided by 2. But your calculator should understand that it has to do this top part first. Okay, then we're going to hit times 6, and you should get a rounded answer of 166.28 centimeters squared. Okay, and again, that's the area of this hexagonal base. Now it tells us they want us to find the volume of the prism. So they want to know how much space is on the inside of this. Well, that's actually fairly simple. We know the area of this end. Okay, now we just have to take that area and multiply it by how long the whole prism is, which is 12. So that's a simple calculation. Volume is going to be area of the base times the height of that whole prism if it was standing on that hexagonal base. So we just got that the area of that hexagon is 166.28. The whole prism is 12 centimeters long, like we were just seeing. So that gives us a volume of 1,995.36 centimeters cubed, because it's volume now, 3 dimensions. This was squared because it's 2 dimensions. Last instruction, find the surface area of the prism. So what they're asking for with this, they want to know if we touch all the outside parts, what's going to be the surface area of it. Well, to do that, we have 2 hexagons, but we already know the surface area of 1 hexagon. So we can take that, just multiply it by 2. And then we are left with 6 rectangles that are 8 wide, 12 long. Okay, so we're going to take the area of those 2 hexagons, add them together, or multiply it by 2, and then find the area of 1 rectangle, and then multiply it by 6, because there's 6 of them. So that's where we're seeing this formula. So we can see surface area is equal to 2 times area of the base, that's the hexagons, plus 6 times the area of the side, which is the rectangles. So 2 times 166.28, that's the area of the base, that's the that we found in part A. And then 12 times 8 for the rectangles, multiplied by 6 of them. Order of operations here, we do all the multiplication first. So 2 times 166.28 is 332.56. 6 times 12 times 8 is 576. Add those together, and we get a total surface area of 908.56 centimeters squared. So I know there's a lot of stuff going on with this, okay? It's a lot of smaller separate skills that you understand how to do. So the big thing that's the most helpful is the diagrams that I've drawn up here. Just envision what you're doing for each of the things they've asked you. You know, you're very capable of finding side lengths with Pythagorean theorem at this point. And you've known how to do area of triangles and areas of rectangles for many, many years now. They're just asking you to put it together, okay? So just envision what they're asking you to do and what it'll look like if you break it into its separate parts. And we'll have this page to practice it, and one more other page that we will do on Monday to give you a little bit extra practice with this lesson, and then we'll get into the review and the test for it next week. Okay? Enjoy some nice weather as well. Don't forget to get outside and get some sunshine on you. All right, take care. Bye-bye.